The first example, I really, in some ways, shouldn't be called an example, but we can talk about log base e of x, and this is just the inverse of e to the x. But what I want you to realize is a lot of people will shorthand this and write it ln of x, and so it's called the natural log of x. What is it? It's just the inverse of e to the x. Let's say that this is called the natural log, and it's just the inverse of the function e to the x. And so I can talk about the natural log of e to the fifth, for example. The third rule of exponent says you can pull the 5 down and write this as 5 ln of e. And this is really 5 log base e of e. And if you scroll up, we said that anytime you have log base a of a, you get out a 1. So this is exactly 5 times 1, which is 5. Okay? So that's that. The second thing that I want you to see here is a different way to think about natural log of e to the fifth. You could say, well, this is the same thing as log base e of e to the fifth. And what I want you to realize is whatever this is, let's just call this, let's think of this as like this box right here. Focusing now on this equation. The base to the outside must equal the inside. And so when you're looking at this expression, you can instantly say this has to be 5. This has to be 5 because the base of the logarithm raised to whatever this whole thing reduces to equals the inside. And so when you see this expression, this is saying whatever this whole thing is, it's the power that you put right there to get this. And so the answer is 5. You can somehow see it. What do you put here to get this? You put a 5 there. And so I'm done. All right, so that's one thing. Second thing is, I don't know, let's do log base 2 of 16. Again, I can write this as, well, instead of, you know what, let's just do it directly. Log base 2 of 16. What power do I put on a 2 to get out a 16? And the answer is 4. So 2 to the 4th, why is this the case? Because 2 to the 4th equals 16. So you can go back and forth like that. A couple other things. You might be asked to simplify. I'm not sure exactly what homework problems I wrote down. I forgot. But if you have something like, I don't know, the natural log of a squared b over the square root of c, you can reduce this and you can say, well, the natural log of a quotient, I can write this as the natural log of a squared b minus the natural log of square root of c, because of this quotient right here, using rules of logs. Then I can say, well, I have a product right here, so this is the natural log of a squared plus the natural log of b minus the natural log of square root of c. And now I can say, well, a squared, I can pull that 2 outside, and so I get, this is 2 natural log of a plus natural log of b, and then I can view the square root of c is c to the 1/2, which then I can pull the 1/2 out, and so I can write this as 2 ln of a plus ln of b minus 1/2 ln of c. Another example, I could be asked to find the domain of, I don't know, f of x equals log base 7 of x minus 5. And so the point is, when you see a logarithm, you know that whatever's inside has to be bigger than 0. And so you would just set, x minus 5 bigger than 0, so x is bigger than 5. And so you can say that the domain is equal to, open bracket, 5 to infinity. All right, well, you should have everything you need to look at the homework from 3.1 and 3.2.